Welcome back to Building Trust with Built Environments. We are excited to welcome you all to our inaugural open house. We have a fantastic facility here in Leland, North Carolina that we have outfitted with the most advanced scientific tests, and we're going to show them off. From hurricane tests, rain tests, Shimizu machines, and cannon blasters, this place has a lot more than you could ever imagine.
So for those of you who don't know me, my name is Jarrett Davis. I guess I'm kind of the mastermind behind this whole charade. This is our chance to really show all of you what it is that we actually do and a little bit of why we do it. If any adults or anybody else want to follow us, we're actually going to go into the lab where you see material science.
We started out with really being an industry disruptor, and we still are. That's in our DNA. We disrupt the industry. We do so in the social media world, we do that in our professional presentations, and we do that in the R&D world. We're evaluating all these other types of materials such as these. These are just examples of building materials that we assess over the years. We may have manufacturers who want to come to us and say, we know we have a good product, how do you make it better? So we assist a handful of manufacturers doing that as well, or we just simply poke holes in a given material. Part of what we do as disruptors is not being happy with the status quo. We want to push the envelope, and that's why we disrupt. And if a standard is this, we're going to test to this. And that's just part of our everyday nature. Everything you see in this space is high tech and some of the best in the industry. It truly is cutting edge. In the back there, we have what's called a universal testing machine or universal testing instrument. What we do with that, we can test the flexural strength of a panel, we can test shear, we can test hardness, anything to do with the mechanical properties of that panel, we can test. If we move over, we'll come back to that. When we move over here, you'll see two instruments that look like refrigerators. These are environmental chambers, and these are very, very useful. What do these chambers do? We can control relative humidity and temperature to a very, very wide range, all the way up to 95% relative humidity. And we can leave specimens in there for as long as we want and see how it performs, see what the degradation process is, look at things like corrosion. So there's any number of things that we can do with these two chambers, and we use those also on a regular basis. We move over here, you see we have all sorts of different microscopes. We have ovens here that we use for quality control purposes, for water absorption. We can look at halogenation, we can look at things like water resistance, and we can look at fire resistance all within 3 days. So we are very, very nimble, and that's part of what we are as the disruptors, is that nimbleness. We can do things in 3 or 4 or 5 days that big manufacturers can't do in a month or 2 or even a year. That's what we do. I think we'll pivot over to you, Matthew.
Yeah, so Matthew is really kind of our material scientist and really helps us on that entry-level material science understanding of really material properties. But Matthew, you want to kind of tell us a little bit who you are?
Yeah, so like you said, I'm Matthew. My title technically is technical specialist, so I assist these guys in running a lot of these different tests. So what I'm doing is a flexural test, without getting too specific into the nitty-gritty. So it's slow moving, but you can kind of see the graph as it's pressing that force down. You can kind of see where it's tracking there and how much newtons of force is being applied to it. So force right now we're measuring in newtons. We've got 1,300 reaching, and there you go. There's your brake. So, yeah, it's a little loud, and it'll give you the readout, and then you can kind of compare that to the standards and see if did it meet what it's supposed to meet. Yeah, so that's one of the tests. You can do a number of different tests with this. That's flexural. You can do fastener withdrawal. You can do fastener pull through. You can do adhesion test, compression, tension, stuff like that. So, yeah, doesn't really show that it's broken, but it's definitely broken.
You heard it. We're going to go back out, do another little experiment with the kids, keep the kiddos entertained, and then we'll start getting to the big scale stuff. So a lot of what we do in built environments is material science and physics, right? That's really my world, and what I love is physics and how things react and kind of how things blow up a little bit. So when you look at gas and you can expel that gas at a rate, pretty simple to make a rocket. So how do you make a rocket out of film canisters? A little bit of water, a little bit of Alka-Seltzer, builds carbon dioxide, Carbon dioxide, makes things go. Pretty neat. So you guys can continue decorating your rockets and continue doing what you want. Mr. Rick's gonna help you shoot your rockets off, but you guys keep decorating, keep having fun, and we'll keep doing that.
My name's Rick Ross. I'm with Built Environments, technical specialist, but this is where all the magic happens. Without this, Jared's always crying and praying and whatever else. Stressed out. No, this is pretty much where we fabricate everything that we're going to be testing, like, for example, walls and stuff. That's our big thing. We've got some panels over there that we just started. Those will be built out a little bit more. Those are going to be going through like a fire test. We do a burn test on them, and we take readings of that and stuff like that and send it to the customer that's requiring that. This is where everything's manufactured for the testing. We figure things out. I mean, if something has to be built or something like that or made for a mold or something like that, we figure it out and we do it, and then we just start doing it on a bigger scale.
Where's Doug? I just saw him. Doug, come here. Everybody loves, we call him Captain Doug. Or Doogie. So Doug, tell us what you do here.
Well, I help with pretty much everything around here now.
Yep.
Rick and Matthew and all, but I'm going to be overseeing all the home construction.
Right.
So we're starting some home construction soon. Finally pulled our first permits.
Yay. Some of you guys are excited.
And that's pretty much going to oversee all that.
And then I also want to introduce my good friend, and that I've known for a lot of times. He's kind of a theme, but Mr. Czech Kiravong. And allow Czech to introduce himself a little bit.
Hello everyone, I'm Czech Kiravong. I've known Jared since 2013. I actually used to be a client of his. I used to work a lot of different industry. So I help with the engineering, and my wife supports the architectural side.
So Czech is a civil engineer from Clemson University. We don't hold that against him.
Okay.
Yeah, absolutely. So we took things on a micro scale, and now we're going to put things in an assembly test. When you do construction of homes and buildings, we have wind ratings that we have to design to, right? So we have to think about what happens during a storm event. Most cladding actually isn't blown off buildings, or roofs aren't blown off buildings. It's actually sucked off buildings and negative pressure. So we're going to demonstrate and show you positive pressure and negative pressure. So this is a pretty typical commercial wall. We're going to do this one here first. And we have, you can see it's a steel stud construction with gypsum. And you see the plastic over this, and we call it bagging. We do testing world. So this is a certified test that we can do for product testing. We can do for other manufacturers, well, our own materials. And we put the plastic over the face so we actually get the wind force on the whole wall. So it's uniform across the face. That's the reason for the plastic. So we're going to start at 20 PSF in the first case, which is equivalent to about a 90-mile-an-hour wind event. And you'll hear it click on, and you'll start to see the bag suck in a little bit here. It's sucking all the air out. And you'll hear the wall start to move a little bit, right? Typically, when we're doing this testing, we have gauges that we put on this. We have lasers. We're actually measuring that wall as it's moving. So we know exactly to the thousandth of an inch how much it's moving. And I'm going to start backing up. See it bounce back? So now what we're doing is we're switching. This is going to be negative pressure, okay? So instead of sucking in the wall, we're actually going to blow the air out. So don't start it yet, Matthew, because I'm still standing here. So, so it's a similar idea. It's the exact same wall assembly, except for this one, we're testing how long the cladding is going to stay on the wall. So if you notice, the plastic is in front of the cladding here, and here it's behind the cladding. So we're actually pushing on that cladding to see before it releases between the sheathing. So obviously we call that a failure. We talked about the YouTube channel. I want to bring up Bree.
Hello, everybody. My name is Bree Okamoto, and I joined the Built Environments team last year. Right around October, we met, and they told me what they are doing and their vision behind it, and I just totally got on board. It's very rare you meet somebody in a company that actually wants to make a positive difference on this earth and save people instead of putting profits first. So I love this company. I love everything we do here. And my job is to get this message out here. So please do follow my LinkedIn, follow my YouTube as a personal favor to us. It means a lot to us to have that, and we put a lot of time and energy into these videos. So hope you guys enjoy.
So these guys are in the process of changing out our wall assemblies, and we can actually then now start introducing water to the pressure, and we can start looking at construction techniques and actually installation methodologies. So we're going to flip out our positive pressure wall, and we're going to put in this wall, which is a pretty normally framed residential construction wall. But this is what we call a DP50 window, or design pressure 50, which is, again, that barrier to entry in the market, right? So a DP50 should withstand design pressure of 50 in use on your residential project or multifamily project or commercial project. So we're going to apply half of that pressure. Instead of a 50, we're only going to do about 25. So again, you saw 25 on the positive. Doesn't really do a whole lot, so you're welcome to walk up. This is incredibly safe. Nothing's going to happen. What we're looking for is water intrusion. You're actually going to see it on the inside of the window in the butt. Let me know when you start seeing water, if you start seeing water. So we're going to leave this test running for a little while so you can all come in and look at the water. We're just going to let it run. Then we're going to start to see the cannon, and then you're going to start to see large missile impact. We talked about wind speed and power. Your hurricane over there is still running. This is only at 38 miles an hour. So think about that, right? So we're talking about 38 miles an hour of a projectile going through. It takes a little bit more wind to move it, but not as much as you think. Typical residential construction, fiber cement, wood sheathing, not exactly a whole lot of resistance there.
Thank you all so much for joining us today. If you have any questions about the things you've seen in this video, please send them in to our team, and I'll make sure they get answered by one of our expert staff. Till then, we'll see you in the next video.